Hello everyone, this is Irene and this video is all about parallel pipe network. What we call parallel pipes are those type of pipes who have same notations, same placements, and same arrangements. So for pipes in parallel, the total flow is the accumulation of flow from each branch in the system. Also, since the flow takes the path of least resistance, the head loss for each branch will be the same. Pipes in parallel also has its properties. According to the continuity principle, the rate of inflow in pipe 1 is the same as the rate of outflow in pipe 2. It is also said that the discharge in the main pipe is equal to the discharges in each of the parallel pipes, and the head loss in each parallel pipe ABC is the same. Another is that the total head loss is the summation of the head losses from pipe A, B, and C. Example number 1. Given the following data for 3 pipes in parallel. Pipe 1, 2, and 3, given the length and the diameter. Pipe 1 is 500 meters long and 350 millimeters in diameter. Pipe 2 is 600 meters long and 400 millimeters in diameter. Pipe 3 is 700 meters and 550 millimeters in diameter. The total flow is 0.74 cubic meters per second. Assuming n is equals to 0.013 for all pipes, evaluate the following. A. The rate of flow in pipe 1, B. The rate of flow in pipe 2, and C. The rate of flow in pipe 3. So, considering this figure, since this is parallel, we can say that the head loss from 1 is equals to head loss from 2 and is equals to the head loss in 3. Or we can say that HF2 is equals to the head loss in 1, or HF3 is equals to the head loss in 1, or in with the continuity principle, we can say that the total discharge is equals to the discharge in pipe 1 plus discharge in pipe 2 and discharge in pipe 3. And since we are given a roughness coefficient which is equals to 0.013, we can use the Manning's formula, which is head loss is equals to 10.29 n squared L q squared over d 16 over 3. So, we will now use the equation HF2 is equals to HF1 in order to get the value of Q2 in terms of Q1. So, equate the two equations. So, using the Manning's formula, 10.29 n squared L q squared over d raised to 16 over 3 is equals to 10.29 n squared L q sub 1 squared d raised to 16 over 3. So, same man sila, we can cancel out the 2 and what's left is only LQ squared over d raised to 16 over 3 and is equals to LQ sub 1 squared raised to d 16 over 3. So, plugging in the value of pipe 2, we have 600 meters over the diameter 0.40 raised to 16 over 3 q squared q sub 2 square is equals to the length of pipe 1, which is 500 meters over the diameter 0.35 raised to 16 over 3 q1 squared. So, plugging in the calculator, we get the value of q sub 2 squared, which is 79,523 q squared, and the other side 135,084.99 q1 squared. So, in order to get the value of q2 in terms of q1, we divide both sides by 79,523. So, q sub 2 squared is equals to 1.70 q sub 1 squared. So, to simplify, we square root the both sides. So, q squared q sub 2 is equals to 1.30 q1. So now we will get the value of Q3 in terms of Q1 using the equation HF3 is equals to HF1. So same process, LQ sub 3 squared over D raised to 16 over 3 is equals to LQ sub 1 squared over D raised to 16 over 3. So plugging in the values of pipe 3, we have 700 meters in length over the diameter 0.550 raised to 16 over 3 Q sub 3 squared is equals to the value of pipe 1, which is 500 meters over the diameter, which is 0.35 raised to 16 over 3 Q1 squared. So plugging in the value in the calculator, so we get 16,975.80 Q sub 3 squared. Yes. And then sa other side is 135,084.99 Q1 squared. So in order to get the value of Q3 in terms of Q1, so we divide both sides by 16,975.80. So Q sub 3 squared is equals to 7.96 Q1 squared. So simplify. So Q sub 3 is equals to 2.82 Q1. So now that we already get the value of Q2 and Q3 in terms of Q1, we can now use the equation QT is equals to Q sub 1 plus Q sub 2 plus Q sub 3. So we have a discharge of 0.74 is equals to the unknown Q1 plus Q2, which is 1.30 Q1 plus the Q3 2.82 Q1. So shift solve, we get the value of Q1, which is 0.144 cubic meters per second. So now it is much easier to solve for the Q2 by multiplying the value of Q1. So Q2 is equals to 1.30 Q1. So 1.30 times the value of Q1 0.144, we get the value of Q2, which is 0.19 cubic meters per second. Same with the value of Q3. So we multiply 2.82 Q1, 2.82 times 0.144, we get the value of Q3, which is equals to 0.41 cubic meters per second. So now, we finally get the value of the rate of flow in pipe 1, pipe 2, and pipe 3. Example number 2. Pipeline 1, 2, and 3 are connected with parallel to each other, with pipeline 1 having diameter of 350 mm, 500 meters long. Pipeline 2, 300 mm diameter, 600 meters long, and pipeline 3 is 400 mm diameter, 700 meters long. The three pipes carries a combined discharge of 0.95 cubic meters per second. Assuming F is equals to 0.02 for all pipes, find the discharge at pipe 1, 2, and 3. So, considering the figure, we have pipe 1, 2, and 3 that are parallel with each other given the length and the diameter. So, therefore, we can say that head loss 1 is equals to head loss 2 and equals to head loss 3. And with the discharge, we can say that Q is equals to Q sub 1 plus Q sub 2 plus Q sub 3. So, this is now our equation 1. So, we can solve for Q2 and Q3 in terms of Q1. So, Q2 is equals to Q1. So, Q3 in terms of Q1. So, we can use the equation HF1 is equals to each of 2. So meaning we have two discharge, the Q1 and Q2. So since we are given a friction factor, we can use the Darcy-Weisbach formula, which is head loss is equals to 0.0826 FLQ squared over D raised to 5. So equating the two equations, so we have 0.0826 FLQ 1 squared over D sub 5 raised to 5 is equals to 0.0826 FLQ sub 2 squared over D raised to 5. So they are same, so we can cancel. What's left is only LQ sub 1 square over D raised to 5 is equals to LQ sub 2 square over D raised to 5. So plug in the value of pipe 1. We have a length of 500 meters over the diameter, which is 0.35 raised to 5 Q1 square is equals to the value of pipe 2, which is 600 meters over the diameter, which is 0.3 raised to 5 Q sub 2 square. So plug in the value in the calculator, we get 95,198.43 Q sub 1 square. On the other side, we have 246,913.58 Q sub 2 square. So to get the value of Q sub 2 in terms of Q1, we divide both sides by 246,913.58. So Q sub 2 square is equals to 0.3856 Q sub 1 square. So simplify. So Q sub 2 is equals to 0.6210 Q sub 1. Next is we will get the value of Q3 in terms of Q1 using the equation head loss 1 is equals to head loss 3. So we already get the value of head loss 1. So plug in, we have 95,198.43 Q sub 1 square. So equals, plug in the value of pipe 3, we have 700 over the diameter, which is 0.4 raised to 5 Q sub 3 squared. So 95,198.43 Q sub 1 square is equals to, plug in the value in the calculator, we get 68,359.38 Q sub 3 square. So to get the value of Q3 in terms of Q1, we divide both sides by 68,359.38. So Q sub 3 squared is equals to 1.3926 Q sub 1 squared. So simplify, square root. So we get Q sub 3 is equals to 1.18 Q1. So now that we have the value for Q2 and Q3 in terms of Q1, we go back now to the main equation, which is the Q is equals to Q1 plus Q2 plus Q3 to get the value of the discharge at pipe 1, 2, and 3. So we have a discharge of 0.95 equals to the Q1 plus the Q2, which is 0.6210 Q1 plus the Q3, which is 1.18 Q1. So shift solve, we get the value of Q1, which is equals to 0.3392 cubic meters per second. So same with Q2, just multiply the value of Q1. So we have 0.6210 Q1. So 0.6210 times 0.3392, we get Q2 is equals to 0.2106 cubic meters per second. Same with the discharge at 3, which is equals to 1.18 Q1. So 1.18 times 0.3392, we get 0.4002 cubic meters per second. So now, we already have the discharge at pipe 1, pipe 2, and pipe 3. Example number 3. The flow rate of water through the pipe system as shown in the figure is 60 liters per second under the total head loss of 12 meters. Assume a Z coefficient of 110 for all pipes. So pipe A, B, C, and D, given the length and the diameter, so A is equals to 350 meters with a diameter of 220 millimeters. B is 180 meters and the diameter is unknown. C is 280 meters and 170 millimeters in diameter. D is 530 meters and 245 millimeters in diameter. So find the head loss in line C in meters. B, calculate the flow through line C in liters per second, and C, determine the diameter of line B in millimeters. So since our discharge is still in liters per second, we have to convert it into cubic meters per second. And we all know that 1 cubic meter is equals to 1,000 liters. So converting 60 liters per second, so times 1 cubic meter over 1,000 liters. So we get 0.06 cubic meters per second. So in A, we are tasked to find the head loss in line C in meters. So we will use the total head loss equation, which is HFA plus HFC plus HFD. So since this is parallel, we can say that HFB is equals to HFC. And in terms of inflow, so discharge is equals to the outflow in QD, which is equals to 0.06 cubic meters per second. And so since we are given a say coefficient, we can use the Hazen-Williams formula, which is HF is equals to 10.67 L Q raised to 1.85 C over C raised to 1.85 and D raised to 4.87. So plug in the value of line A, we have 10.67, the length of 350 times the QA, which is 0.06 raised to 1.85 over 110, 1.85, the diameter, which is 0.22 raised to 4.87. So plug in the value in the calculator. We get HFA is equals to 5.466 meters. So the same process, we will get the head loss at line D using the same formula. So plug in the value of line D. We have 10.67, the length of 530 times the discharge of 0.06 raised to 1.85 over the C coefficient 110 raised to 1.85 times the diameter 0.245 raised to 4.87. So, plug in sa calculator, we get head loss at D is equals to 4.90 meters. Now we have the value for HFA and HFD, so we can get the value of head loss at C using the equation total head loss is equals to HFA plus HFC plus HFD. So we have a head loss of 12 meters equals to the HFA, which is 5.466, plus HFC plus the HFD, which is 4.90 meters. Shift solve, we get the value of F, which is 1.63 meters. So using the value of HFC, which is 1.63 meters, we can get the QC using the formula. So 1.63 is equals to 10.67 times the length 280 QC raised to 185 over 110 raised to 1.85, and the diameter, which is 0.170 raised to 4.87. So we have the value of QC, which is 0.018 cubic meters per second. But this is not the final answer since we are required to get the value in liters per second. So we have to convert 0.018 into liters per second. So 0.018 cubic meters per second times 1,000 liters over 1 cubic meter is equals to 18 liters per second. So in order to determine the diameter of line B in mm, we can use the equation QA minus QC is equals to QB, or just the same as QA is equals to QC plus QB. So plug in the value QB is equals to 0.06 minus 0.018. We get the value of QB, which is 0.042 cubic meters per second. So we can use this, plug into the formula to get the diameter. So 1.63 is equals to 10.67 times the length 180 times 0.042 raised to 1.85 over 110 raised to 1.85 times the diameter 4.87. So we have the diameter in B is equals to 0.21 meters, or in mm is 210 millimeters. Now we're done. We already have the value of head loss in C, the flow in line C, and the diameter in line B.